Is V ref on the top inverted?
Yeah, I'll talk about that. Okay, looking at designing Schmitt triggers, it's surprisingly straightforward. If you look at the notes on the regeneration, you don't have to make a meal out of it. Okay, you need to show you working, but it isn't as hard as it looks like. It's effectively, if you remember that voltage across a resistor is proportional to the resistance. If you've got the same current going through two things, then the ratio of voltages will equal the ratio of resistances. Okay? So, in effect here, we can look at this here. This is a non-inverting Schmitt trigger. We can tell that because Vin is connected here to the non-inverting input. Okay? If we flick it the other way around, we'd have V ref here and V in there. It would be an inverting Schmitt trigger. Okay? That affects really, doesn't affect the switching thresholds, but affects the calculations and affects which way around your graphs end up coming out in your histogram and hysteresis curves as well. So, what's the value of V ref? So, a non-inverting Schmitt trigger is required to have a saturation values of plus or 9 volts and switching thresholds of plus or minus 4 volts. So that tells you if the switching thresholds are symmetrical, like that at plus and minus, then V ref must be 0 volts. Okay? Now we know from that when at the moment the Schmitts shift from one state to another, the switching thresholds, V ref equals X only at the switching threshold. So at switching threshold, V ref equals X. Okay? So that means we know that is there, 0 volts. Yeah? That means we can make saturation value here of plus 9 volts. Okay? And switching thresholds of plus or minus 4 volts. Can that be plus 4 volts? Ask yourself. No, it can't, because it's going plus to 0, if you're going back up to plus. That can't happen because there's nowhere for the current to go. It can't go in there, so it's flowing down this way. So this therefore must be minus 4 volts. Okay? So now we have to work out the resistor values. Okay? And you can just say, because voltage is proportional to resistance, we can literally say, well, we've got 9 volts across here, so we can make that a 9 kilo ohm. We've got 4 volts across this resistor, so we can make that a 4 kilo ohm. Now, it doesn't matter what, no, that could be 18, that could be 8, that could be 4.5, and that could be 2. That could be 90, that could be 40. So the way to write it is that the voltage over R1 divided by the voltage over R2 is equal to value of R1 divided by the value of R2. So therefore, 9 over 4 equals, and we can either say 9k over 4k, because it's got to be kilo ohms, or else you won't get your marks, or you could say, I don't know, 90k, doesn't matter what you do, as long as it's above. And that equals R1, and that equals R2. Quite easy to get me.
Does it ever not? Is it ever not as easy as that way?
Not really. The only difference might be is that the voltage reference isn't 0, but they'll make it so it's got to work the question. So as long as you put the voltage reference correctly and make that correctly, make that correctly and make that correctly, it's always the same.
Do you have to? So you never minus the reference voltage. Say that the reference voltage was 2.
Yeah, well that would mean this would be 2.
Yeah.
So you'd have 7 volts across that
Oh,
resistor,
so it'd be 17.
and that would be 6 volts across that one, wouldn't it?
Right, yeah.
Yeah.
Well, but it's like it's not none of it inverting.
If it's non-inverting, we'll do a non-inverting if we find a non-inverting. Hang on.
Wait, is that inverting or non-inverting?
That's non-inverting, isn't it? Right, I've got an inverting one here, hang on.
Yeah, it'll state it. It'll state it sometimes.
You just do the inverting by the
Okay, we'll try another one.
Yeah. It just says that. Yeah, you don't have to
Okay. So now we've got an inverting one. So V in is up here now. Okay, to confuse you. What's the value of V ref? Switching thresholds are plus or minus 5 volts. They're not going to ask you that unless they're either going to tell you that or it's going to be symmetrical, because if it wasn't symmetrical, it's hard to work out. Okay, they're not going to do that. So V ref must be 0 volts because it's symmetrical. Oops, making me yourself dizzy. So we'll have V ref is 0 volts. So that we need to establish the voltage everywhere, don't we? Okay. Now, the saturation value is plus or minus 15 volts. So we can make that plus 15 volts. And we need to know what X is. Well, X and V in must be equal at switching thresholds, mustn't they? So we've got switching thresholds of plus or minus 5 volts. So is that going to be 5 or minus 5? Why is that?
Because it's a 0.
Yeah, because it can't go minus 5 and back up to 0, so this must be now 5 volts. So again, the voltage over R1 divided by the voltage over R2 equals R1 over R2. Yeah, same thing again. So what have we got over this one? 10. So we've got, which equals 10k over 5k. So that could be, therefore R1 could be 2k and R1 could be 1k. As long as they're double, it doesn't matter.
Right, yeah.
Okay? Make sure the kiloohms, and make sure you show that ratio as well, so that's working out, isn't it? If you just put the answers in, you might not get all the marks, even though it's quite easy. Now if you look at the notes, they do have to make that a bit tricky, but it's still there. Okay? I'll just stop the recording.